Universal Gravitation Part 3, Newton versus Einstein. Newton's law of gravity that we've been practicing for 2 days beautifully explains 3,000 years worth of orbits and all, or almost all, the astronomical data in the solar system and beyond. It explains the motion of binary star systems, 2 star systems orbiting around each other, the spinning of galaxies, and all the other major features of deep space. In fact, Newton's law of gravity perfectly fits everything that Isaac Newton and his contemporaries could see from a telescope, with one small detail. Mercury, the closest planet to the Sun. It follows an elliptical orbit. Just like every orbit we've seen, it moves faster when it's closer to the Sun. It moves slower when it's far away from the Sun. But unlike all the other planets and every other speck in the night sky, the orbit of Mercury doesn't stay in the same orientation. The ellipse shifts. In fact, it shifts by 43 arcseconds per century. It's not something that Newton would have ever been able to track in his own lifetime, or Kepler in his, but looking at the data charted by Tycho and Sophie Brahe, and Kepler, and Galileo, and Newton's contemporaries, spanning more than a century, a very, 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 very tiny shift might have become apparent. There's nothing in Newton's law of universal gravitation that would explain why the ellipse moves, and that the ellipse now is oriented several arcseconds differently than in Newton's time. More tellingly, Newton's law of universal gravitation does not explain gravitational lensing. We've seen with our superpowered telescopes that not all light travels to us in straight lines. Optical illusions and other tricks of the light, every time we take a look at a very large mass, make it patently clear that gravity affects light. The light from a faraway galaxy does not travel in a straight line path to us. It bends around large masses in its path. This is insane. If this is true, everything Newton has taught us about gravity is wrong. Newton said that gravity was a force between 2 masses. Why should light be affected by a force if it doesn't have any mass? Look far, far out into the night sky, and you will see gravitational lensing. You will see swirls of light, like somebody doing Photoshop on your display, as you try to look past very large masses. This is the light bending around something very big and something very heavy right here. According to Newton's law of universal gravitation, light should not be able to do that, but it does. Gravity also affects the flow of time. We call this time dilation, and in the 20th century we were able to prove to the nearest nanosecond that clocks in strong gravitational fields run more slowly. Kip Thorne's Interstellar does a tremendous job in making this comprehensible to Hollywood viewers, because when our heroes go visit other planets, they find that 1 hour of research on the heavier planet takes 7 years on Earth. Time is flowing more slowly for them than it is for the Earthlings, and this drives their plot to get home in a hurry. This is exactly what time dilation looks like in the real world, and it's a common feature of deep space. 1919. Einstein has been thinking about this for 15 years, after the approximately 1 year it took him to work out and publish the laws of special relativity. Einstein posits that space and time are intricately connected. There are a certain number of meters of space in 1 second of time. Specifically, there are 3.0 times 10 to the 8th, 30 million meters in a second of time, a constant that we have heretofore called the speed of light. Einstein explains that mass warps space and changes time. That's what it does. It's mass. The presence of mass fundamentally alters three-dimensional space, and with that, it alters time as well. Space becomes more dense. There's more of it near the planet. And more space means less time. What does this look like? Well, the common painting of this, trying to envision a 4- or 5-dimensional problem as a 2-dimensional work of art, looks like the bowling ball on a mattress model. The Earth has a lot of mass. The Moon has a small amount of mass. If we try to send something moving straight through along this line, that something will go past. But if we try to send something straight through along this line leads straight and true to a crash landing on the Earth's surface. That's, Einstein explains, is what gravity does. It's not that the Earth is providing a force that will pull you in. It's that the Earth is warping space so that by following a straight line, you naturally go straight to the surface. Einstein's law of gravity says that mass warps space and time, that everything in the region will follow warped paths. This is where Star Trek gets the idea of warp speed. We call these warped paths orbits, and they're our next topic in the science of space.